All right, good morning, everyone. Have you taken your breakfast? Okay, good. Okay, so, before we start the lesson, probably we can spend a few minutes to do some housekeeping for the class. So for today's session this evening, we will have an online replacement for tutorial and practical section 8. The class on Tuesday because I have to cancel that class. Okay, so the replacement session for online tutorial and practical section 8, the link for the online meeting is already available in the announcement. So you can click on this link for our class this evening. All right. So unfortunately, there is no physical venue available. So that's why we have to conduct this online. Okay. All right. And then, so that is one announcement, okay, for students in tutorial and practical section 8. All right, another announcement is that next Monday and Tuesday onwards, okay, for Monday and Tuesday session, from next week onwards, Dr. Akibu, okay, will take over the class, okay. So you will meet your new tutor next week. Okay, only applicable for Monday and Tuesday sessions. Okay, right. So that is the second announcement. The third announcement. All right. So next Thursday will be public holiday. Okay, due to Deepavali. Okay. So for the students of the following sections. Okay, tutorial 10, section 10, which is on the late Wednesday evening. All right, and then of course, the classes on Thursday all will be cancelled. There will be no class on Thursday because of the public holiday, including Mr. Chew's class, okay, tutorial 1 and practical section 1. All right. So since there will be no class and we have to arrange placement for quite many sessions, so for my class, okay, which is section 10, 12, and 6, okay, I will conduct another online replacement session on Friday as well. Right, so I will share the Microsoft Teams online meeting next week, and then this session will be recorded. So if in case you have another class to attend, right, so you can watch the recording later, right? So all the online meeting will be recorded. If in the case that some students might have to attend another class or another events. Okay. And for Mr. Chew's session, for practical section 1, he will inform about his arrangement for replacement, okay, to his class. Okay, so basically that's all the announcement that I would like to make for today. Okay, so please observe the announcement, and if you're not so sure what the announcement is all about again, please come to the announcement section and check the latest 3 announcements that I had just recently made. Right? Okay, and then another one that I would like to inform as well is on the plan for your midterm test. Okay, your midterm test, if you can see in the weekly plan, so you can go to the general section here. There is one link for weekly plan, so you can open the weekly plan. Okay, so if you look at the weekly plan, your midterm is scheduled on week 7 during the lecture session. Right, so you have to attend your lecture session. Right, and it's going to be, at the moment we are planning to make it written on paper. It's a paper midterm test. Okay, so as a way to prepare you as well to sit for your final. Your final also is written test on paper. Okay, so let's start from the midterm. So let's have that exposure, okay, to write your answers on paper. All right, so week 7, during the lecture session, okay, so the midterm test will cover lecture 1 to lecture 4, tutorial 1 to tutorial 4. Okay, so please take note. All right. So practical, there will be no covering in the midterm and also final. Okay. All right, so basically that's all about the midterm. So let's move on to the assignment. All right, for the assignment, I have uploaded the group assignment handout in week 5. So you can go to week 5 section here, right? And then you will see group assignment. So let's go to the group assignment. I will spend maybe around 10 minutes or to discuss about your assignment. So you can observe here, your assignment is already available for you to download since Monday, last Monday. And the due will be on Sunday, 15 December 2024. Okay, so when is this 15 December? Let's look at the weekly plan again. 15 December is in week 12. Okay, so week 12, you have to already submit your assignment report and your Cisco Packet Tracer file as well, your design. Right? And then in week 13, before the holiday week, we will have our presentation. Okay, it's going to be real live presentation during the practical section. So you will present to your tutor, and your tutor will ask some question for you to demo, okay, your design. Okay, right. So make sure, please observe when will be your presentation session, your practical section, and buy the ticket for your holiday accordingly. Okay, all right. So make sure you attend the practical section. Sorry, the assignment presentation. Okay, all members should be present. Right, so observe the dates. So for the group assignment, I have uploaded the cover page. So let's go to the cover page here. Okay, so it's going to be, if you open this in Word document, it's going to be just in one page. So for the cover page, all members need to write the names and ID, and all of you need to sign. Okay, so all members should sign this cover page. So your signature will indicate agreement on sharing the marks. Right, so there are a few situations where in the previous semester, there are teams that one or two members did not sign the cover page. Okay, so it indicates that could possibly be the sleeping members, the MIA ones. Okay, so that one we would like to avoid as much as possible. Okay, so please make sure, okay, your team members sign the cover page. Okay, on the cover page, you have to indicate who is the team leader, right? And then your tutor name, okay, the lecturers who teach your practical section. Okay, and then you also need to indicate the number of pages, okay, for your report. Number of pages should not include cover page, table of content, and also references. It just counts the content of your actual report, okay, or your design. Right? So once you submit, please make sure that all members have a copy, okay, in a situation where your team leader's PC maybe crash or something, then other members do have a backup. Right? Plagiarism, try to minimize this as much as possible. Collusion. Okay, so let's say you work together. Okay, some teams work together, okay, on the design and also on the report. Make sure that the report and the file should not be exactly the same. Right? So the arrangement, the words that you use to explain and to describe should not be exactly the same. Okay, although the understanding would be the same. Right? Okay. And declaration, of course, when you submit, everyone agree. Everyone that signed this page agree, okay, for the submission. All right, so this is the cover page. So let's look at the handout itself. Okay, so this is the group assignment handout. So the objectives of this assignment is basically to let you have some exposure and experience to design and configure a LAN topology, a network topology, by applying basic principles of wired and wireless network. You have to set up wired and wireless network, together with the configuration of network devices by using Cisco Packet Tracer simulation tool. So you'll be using Cisco Packet Tracer this semester. Okay, and you are also expected to be able to understand the IP addressing scheme. Okay, at the end of the lesson, you should be able to propose a basic network operation solution whereby you have to report your design and you also need to present your design. Okay, all right. So here is the design scenario. Okay, if you do have question, please ask. Okay, if you need clarification, please let me know. So you will build a simple network using the Cisco Packet Tracer from scratch. Okay, so there's no predefined file that you will start with, all right? And then you have to save the network file as Packet Tracer activity file .pkt. Okay, there are several file types extension in Cisco Packet Tracer, so you will save your file as .pkt. All right. So there are 4 parts to this assignment. So part 1. Okay, your team will design a network for a middle-sized company. Okay, and the connection to the internet will be provided by some ISP. Okay, one internet service provider. The company is basically occupying 1 floor, okay, in the building, right? And the network in the building should service at least minimum 20 employees, right? So at one time, minimum, you should be able to service 20 employees. Okay, so all of the employees will be residing in 1 floor, in the same floor, right? So the following are the requirements for the floor. Okay, so at times, the network on the floor should service 30 employees. Okay, 30 employees at times. At least minimum 20, it can go up to 30s. Okay, so each employee should have at least 1 wired, okay, cable connection, okay, and 2 wireless connections. 1 laptop and 1 for mobile phone. Okay, so each employee will have 3 connections basically. 1 wired, 2 wireless. And the wireless is for 2 different devices, mobile phone and laptop. Okay, the company as well would like to make 10 additional wireless connections available for visitors that might be present on this floor. So the company may be receiving some visitors. Okay, so at most around maximum up to 10, minimum up to 10 visitors. So you can prepare like a reserve, okay, 10 wireless connection for the visitors. The floor contains 3 printers. Okay, so you're going to have some printers. And the floor as well contains the router. Okay, so this router will be receiving the connection from the ISP, and there'll be the switches, okay, that will service the floor because you have many laptops here. Okay, via the internet, the employees in the company should be connected to 2 external servers. Okay, so you're going to have servers, okay, in the internet, right? So the employees of the company should be able to access the servers on that internet. Okay, and at the same time, okay, so we will also add on some IoT. Okay, the company will utilize CCTV technologies, okay, to secure the floor, and the main door is accessed using RFID smart tag technology. So there are 2 IoTs here. One is the CCTV camera, and another one is the RFID smart tag for the smart door. So like a smart door lah, right? We call it smart door. Right, so there are 2 IoT kind of sensors. Okay, so these are the requirements. Right, so here I have prepared for you the addressing schemes. Okay, so you need to figure out as you learn and complete your modules, Cisco Packet Tracer module in the Cisco Networking Academy, you will learn how to set up the addressing schemes for each device. So don't worry. Okay, so this is the addressing scheme for the device. So I have listed down all the devices, and then the interface that you will use to set up the network, okay, and the IP addressing scheme, okay, for this for each device. So we will learn later on when we go into the network topic. Then we will learn what is DHCP and whatnot. Okay. We have IP address, subnet mask, and also default gateway. Okay. And then once you have complete your design, you have to verify the connection. You have to use some command to make sure that all the devices in your design can connect to each other. Okay, all right. So here is some verification that you need to test. Okay, first is to refresh the IPv4 settings on the PC. Okay, refresh and then verify that the laptop can be connected to the internet, to the server, and so on. Okay, so these are the verification steps, and this is what we will test you in the presentation. We will ask you, okay, can you connect this PC to this server, or this PC to this PC, and so on. Okay, all right. And then save the file. Okay, save the file as .pkt. All right, for the submission, the group assignment, okay, must be completed in a group of 3 to 4, 3 or 4 or 5, okay, and all members must be from the same practical section, okay, practical section. And you have to register your team members here, so you can click on the link, so it will bring you to the Excel sheet. So I have prepared the Excel sheet by tab, okay. So look at your practical section and register your team accordingly. What's this? Okay. Okay, let's say lab group 4. Right. So here is the tab for lab group 4 member registration. Okay. So register by according to your practical section. Okay. All right. And then I lost it. Okay, hang on. Okay, and then the assignment, okay, report must be submitted only by the team leader, so team members do not have to make the submission, and the submission will be made through the Google link that I share. Okay, for the report, okay, the assignment must attach the front cover, okay, prepared for the assignment, so use the same template, okay. All group members must digitally sign and agree on the submission condition. And you also need to include in the assignment rubric, okay, after the front cover. Where do you get the assignment rubric? It's here. Okay, so you need to include these 2 last page. Okay, I will share the doc file as well later, okay, so that you can include the rubric into your report. All right, so these are the rubric that you have to include, so when we mark, we can simply fill up the rubric, okay, for your team. All right. Okay, so these are what we are looking for when we assess your assignment. Okay, documentation. This is for presentation report. Okay, part 1, part 2, part 3, documentation, and also references and citations. Right, and then this is for presentation. We are looking at your configuration ability. You will should be able to demonstrate the organization of your presentation and also your delivery. Okay, delivery-wise, it will go by the student. So each student will have to present, okay? All right, and we will test. We would also ask testing question for every student. So the marking for delivery will be depending on each individual performance, okay, during the presentation. Right. So then, hence, the mark for each student also might not be the same, okay, due to the presentation. Okay. Right. So you have to include this rubric in your report. Okay. And then, okay, in the presentation rubric, all right, you fill up the student ID for all team members, okay, for the delivery criterion and the total marks, okay. Your report must include a table of content. You should provide a table of content. The report should not exceed 15 pages. Alright? So if it goes beyond, then try to crack your head as a team. Alright, so how to cram everything into 15 pages. Okay? So these are the format that you should use to write your report. Okay? And for whatever screenshot that you setting, the configuration, the testing, the command prompt, you should include the screenshots, okay, for each step. And then don't simply include the screenshot, you also need to provide some brief explanation. Okay? Alright, and the submission should be in the PDF file. Okay? Right, so basically that's the basic morning. That's the basic requirements for your assignment. So any questions? Any questions? Yes. 20 marks, yes. Sorry, the report 15, presentation 5. So you can look at the rubric here. So you can see for the report, it's going to be 15%. And for the presentation, it's going to be 5%. So total is going to be 20%. Right? Okay. Any further questions? Okay, I think it's quite straightforward. So remember, in your Cisco Packet Tracer, you have two modes, logical and physical. So you should only focus, you can go up here, on the logical only. So there's no representation for physical. Okay, so just focus on logical. No need to concentrate on the design for the physical layout. Right. Okay. So I think basically that's all for the assignment. Right, because the lab, the practical section are mainly self-paced study. Okay, so I will allocate the practical section, every practical section, as well as the medium for you to consult, to do the consultation with your tutor, okay, about the assignment. Right? Okay. So I think basically that's all. Okay. So if there's no question, then I will proceed with the class. Right, for the class today, right, you will learn lecture 5, input-output. Okay. Right, so this lecture 5 will be covered in the final exam. Okay, there's no coverage for lecture 5 in midterm. Okay, so we will look at how your operating system manage I/O devices. So you can see on your personal machine here, you have many I/O devices, right? What do you have? Okay, on my machine I have mouse, okay, keyboard, right? Okay, this touch panel, and then you have the screen, and then what else do you have? Processor. Processor is not I/O. Okay, processor is not an I/O. Processor is the processor. I/O, input, output. Input means any devices or any component or element that receive input from the external environment, and output is any devices or elements that will display or produce output into the external environment. So that's what we meant by input, output. Okay, so what else do we have here? Okay, yeah, correct, camera. What about memory? Memory also is one type of I/O devices. You have your USB keys, USB. Your hard disk drive also is considered as I/O, okay, your hard disk. And then your communication port, your Wi-Fi module, your cable module that connect your computer to the network also is an I/O. Okay, so your machine actually have so many I/O devices attached to it. So how does your OS manage all these I/O? So this is what we will be looking at in these particular chapters. So to assist you in understanding the slides, okay, I just prepared a Slido. Okay, let me see. I have to log in. Oh, I already have the Slido here. Couldn't see. All right. So let's see. Okay, I'm going to present this one. Okay, can you join the Slido? All right. So I hope that by attempting the Slido, in some way it helps you to start digesting the slides, okay, in the lecture. Okay, so let's join the Slido. Okay, give your real name, because at the end of the day, we're going to have some winner. And the winner, you should come to forward and claim some gift from me. Okay. All right, so basically the slide for this lecture, okay, there's some thoughts on the lecture. Okay, we will start with the categories of I/O devices. Okay. So let's start the quiz here. Apparently it shuffled my quiz, Okay, so let's just pick your answers. So these drive and sensors are examples of human readable I/O devices. Is it true or false? Is it human readable? Okay, right, so pick your answers. Okay, right. So this drive and sensors, they are examples of human readable I/O devices. Let's look at the slide here. Okay, so later we come back. Okay, categories of I/O devices. So I/O devices, there are several categories. So as I mentioned, I/O, input, it refers to the devices that receive data or input from the external environment. Okay, like us, we type. The action of typing is basically input to the machine, and then output is the devices that produce outcome, okay, to the external environment. In this case, we have display that you can see the content. So there are three categories of external devices. It could be human readable, machine readable, and communication. Okay. For human readable, this one is referring to the devices that where user can enter input that user can understand. Okay, like what we type here. Okay, we know what is QWERTY, right? And the display that we get from the system also is human readable. Okay, the display on the screen. Okay, so examples are printers, terminals, video display, keyboard, and mouse. And then you also have machine readable. So this one is suitable for communicating with electronic equipment, meaning that machine to another machine devices, right? For example, you want to save your file into the hard disk drive. Okay, so hard disk drive also will be saving your data in 101010, which you will not be able to understand. Okay, but only machine understand that. So that is machine readable, right? And then you have communication. So this device is suitable for communicating with remote devices. So these are referring to the digital line drivers and also your network interface card, like your Wi-Fi module and your cable module, LAN module, okay, to connect your machine to the network. Okay, so these are the three types of categories of I/O devices. Okay, so I hope you picked the right one. Okay, all right. So, okay, let's move on to the next one before I display the next question. So there are the devices may differ okay, in the number of areas. So you can describe the device in certain using these parameters. Okay, so first is the data rate. Different devices will transfer data at different rates. Okay, so your mouse, your keyboard, even your memory, your hard disk will have slower speed compared to USB, for example. Okay, and then application. The use of the devices, okay, will be influenced by the software. Certain software requires a specific device. Okay, so it will depend on the application. Complexity of control, how complex it is to control the device. All right. Unit of transfer, how much data that can be transferred at one time. Does it transfer in the block? Okay, like saving in the main memory or in your hard disk drive, it will transfer data in block, okay, in partition. But if it is about your network communication, okay, chances are it will might transfer in terms of stream, one bit at a time. Okay, so you look at unit of transfer. And then you have data representation. How does the device represent your data? Does it do encryption? Does it use a certain encryption, or does it use a specific character coding, okay, to code your input? Okay, and then error conditions. How the device handle errors. Okay, so different device will handle errors differently. So these are the number of areas that device could differ. Okay, so let's look at the next question. Okay, all right, so 40% true. Okay, so let's try to improve that. Okay, so 60% got it right, 40% do not get it right. Okay, so I/O devices differ in the number of the following areas except, so which one does not? You can't simply use that criteria to differentiate the device. Okay, is it application, error condition, shape, or unit of transfer? Right, so you can pick your answers. Right, so we can move on to the next slides. Okay, so these are the data rates. So you can see the typical I/O data rate for different devices. The slowest one would be keyboard, and the mouse, and then the fastest one is your Ethernet connection. Okay, gigabit Ethernet connection. Right, so how do you organize your I/O? So your operating system, okay, can choose from these three techniques, either one, okay, or it might combine one or two. Okay, so there are three techniques for performing I/O. Okay, the first one is programmed I/O. Okay, so what is programmed I/O? The I/O devices itself is programmed to handle everything. Okay, from initiation, data transfer until completion. So that is programmed I/O. So what happens here is that the processor will issue an I/O command on behalf of a process. So let's say a process wants to use a printer. Okay, so the processor, on behalf of the process, will contact the printer. The I/O mechanism says, I want to use printer. Okay, and then the process will be busy wait, okay, for the operation to be completed before proceeding. Meaning that, okay, the process later on will transfer the data to the printer, and then it will have to wait until the printer complete the printing. And then the the processor will resume the execution of that process. Okay, so this is programmed I/O. Okay, so I repeat again. For programmed I/O, the processor, on behalf of the process, will make a request to the I/O device. Okay, so let's say I have one Word process here, and I want to print. So on behalf of that Word document, processor will knock the door on the printer. Printer, knock, knock, I want to use your service. Okay, on behalf of the process, processor will do that. And then once the printer says, okay, I'm ready, Then the Word document will transfer the data to the printer. The Word document must wait until the printer complete the printing. Okay, and then once the printer inform the Word document, alright, I have complete the printing, then the processor can continue execute the Word document. Okay, so the Word document must wait. So that's what we meant by programmed I/O. Okay, and then you have interrupt driven. So now, what is the difference between programmed I/O and interrupt driven? Okay, for interrupt driven, again, the processor on behalf of the process will issue the I/O command to the device. Similar. So now the Word document wants to use the printer. Okay, so you click on the printer button. Now the processor on behalf of the Word document will knock the printer. Okay, knock knock. This Word document wants to use your service. Okay, so what happened in the interrupt driven is that if the printer is free, okay, if the printer is free, then the Word document will transfer the data to the printer, and the Word document does not need to wait. Okay, so the user can continue using any other services on the Word document. So the processor can continue execute the Word document without having to wait for the printer to complete the printing. Okay, so what happened is that when the printer complete the printing, the printer will interrupt the processor. Hello processor, I know you are doing another instruction, but now I have complete the printing. Can you come and terminate my service? So that's what it meant by interrupt driven. So interrupt driven here means once the processor initiate the communication with the I/O device, the processor can continue executing the instruction for that process or another process. The processor do not have to wait. Okay? Right? If the printer is used by some other processes, okay, so then that process who requests to use the printer will be blocked. Okay, will be pushed into the block state, and the CPU will continue to execute another process. So in other words, in interrupt driven, the processor will not have to wait. Okay, so every time the I/O devices complete the operation, or if there is any issues arise, okay, any condition arising, it will interrupt the processor. Okay, can you stop? Can you entertain my problem first? Okay, or terminate my my service. Okay, so that's what we meant by interrupt driven. Alright, and then there is another module which is direct memory access, DMA. So for the DMA, alright, so this is a chip, okay, a specific one independent chip, okay, produced by a manufacturer, by the developer. And this particular module will control the exchange between the main memory and I/O module. So if the system use DMA, you will see a DMA module on the board, on the motherboard. Okay, so this is another type of technique to manage I/O. Okay, so now technique for performing I/O. Okay, before I move on, let's go to the Slido. Okay, so what is the right answer? Shape. Okay, right, good. Okay, so shape, okay, is not the way, okay, that you should use to describe the I/O devices. Of course, it has a different shape, but it's not one of the area, okay, that you need to look at. Now, look at this one. Which of the following technique refer to the processor issuing an I/O command on behalf of the process? So which technique that requires processor to issue I/O command to the device? You can choose two options. Two, yes, there are two answers here. So choose two. Okay? Okay, I'll let you choose. Okay, let's go back to the slide. Okay, so here you can see, okay, some mechanism may require you to use the interrupt signals. Okay, it might require the process or the processor or the I/O device to interrupt the processor. So here you can see, because this is your I/O, okay, for example, this is your I/O, the Wi-Fi module. You want to transfer data from your machine. Okay, you have your processor, and then your main memory, and then your I/O devices. So usually the data that you want to transfer are not residing in the hard disk. It's very slow to pick up from the hard disk, bring into the processor or main memory, and then transfer that into I/O module. Okay, so usually the data is already residing inside the main memory. So the data transfer between your I/O to your processor is via main memory. Okay, so main memory is serving like a buffer lah. Okay, a space where you will copy the data from I/O and then put inside main memory for processing. Okay, so you can see here from I/O to memory transfer through processor, you will use program I/O. Okay, so the processor knock the printer, okay, and then the processor will transfer the process will transfer the data in the main memory to the I/O. So using program I/O, there will be no interrupt, meaning that the processor will not be interrupted. It will wait until the process complete. Okay, and for the interrupt-driven I/O and direct memory access technique, both technique will use an interrupt mechanism. Okay, meaning that when you transfer data from main memory to I/O, okay, for example, I want to print, so the Word document will transfer the content in your Word, which is saved in the main memory, to the printer. Okay, so once the printer finish, the printer will interrupt the processor. Okay, I have complete. Okay, same thing here for DMA. When you directly transfer the data from I/O to main memory without going through the processor, so again, the DMA also will require to interrupt the processor. Okay, so these two techniques is using the interrupt mechanism. Interrupt here means the I/O device can interrupt the processor. Okay, can stop and halt the process. Okay, so let's look at your Slido here. So which one is the correct one? Okay, interrupt driven and program I/O, correct. Okay, right. So next one, which of the following I/O technique does not use interrupt signals? Okay, choose which one. Okay, choose the right one. This does not interrupt the processor. Okay. Alright, so now let's move on to the next slide. Okay, so these are the evolution of the I/O function. Okay, in the first generation of computer, the processor itself will handle the peripheral devices. It will have direct control. Okay, so if I want to use printer back in the 1980s or 70s, the processor is the one who will initiate the communication with the I/O device. The processor is the one who will transfer the data, and the processor is the one who will terminate the service. Okay, so it has full control over the device. Okay, which is not efficient if you have so many processes to run and so many devices to control. All right. So then you have what we call the controller or I/O module is added. So why not we create a separate module on the motherboard, okay, to handle the communication between the machine, between the processor and the I/O devices. Okay. So same configuration as step 2, but now let's use some interrupt. So why not we don't let the CPU to wait? Okay, it's a waste of time. So while the printer is printing, let's use the processor to execute another instructions. Okay, so then you have interrupts employed. Okay, and then you can see it moved down to DMA. So DMA here is the most recent technique. Okay, not that recent. Okay, it's been there I think maybe around 15 to 10 years already. Okay, so this is the evolution from program I/O to interrupt driven and then to DMA. Okay, so how does this DMA looks like? Okay, so you have DMA, and then nowadays, okay, the recent invention, even your I/O device has its own processor. Your printer now, okay, it can do processing on its own, and it also has its own local memory, right? Your printer, sometimes you can print without having to connect your printer to the laptop or PC. Okay, so that's the evolution of the I/O devices. Now we look at the DMA. Okay, how does this DMA looks like? Okay, so this DMA, as I mentioned, this is one chip on its own on the motherboard. Okay, so it has control logic, it has address register, it has data register, and data count. So what happens is that this DMA module will handle the data transfer between the I/O devices directly to main memory without having to go through the processor. So the processor does not need to know that there is a data transfer happening. Okay, all right, so the processor can be used for another task. Okay, so what happened here is that how do you transfer data from I/O devices to the main memory? All right, so of course here the DMA will have some control logic. Okay, so first of all, the processor will need to make some requests to the DMA. Okay, I need to transfer data from the printer. Okay, so printer, please copy. So the processor need to make a request, okay, to the DMA. Right, and then so you need to indicate as well what operation you want to do. Do you want to read or do you want to write? Do you want to, for example, if you are writing, saving from hard disk drive or your USB key, you need to inform what do you want to do here. You want to save a file or you want to open a file? Okay, read or write, right? So once you indicate what you want to do, all right, the process will inform you where to save or where the file is within the main memory. So this is the address line. Okay, it will go into address register. Okay, and then the data line here will be used to transfer the data. Okay, so the data that you transfer will go into data register, and it will count how much have been transferred between the I/O devices and the main memory. Okay, so this is how the DMA works. All right, so here let's just go through the DMA roughly, and then we will end the session. The rest we will discuss in the tutorial. Okay, so you can see here, the CPU, the device driver is told to transfer some disk data from the hard disk to buffer at address X. Okay, so the device driver will tell the disk controller, okay, to transfer C bytes from disk to buffer at address X. So you got your CPU here, you have your cache, and then you have your bus, and then this is your RAM. Okay, so now you want to copy data from your disk drive, hard disk drive, into the memory. Okay, so of course this processor need to tell what to copy and from where. All right. So and then number 3 here, the disk controller will initiate the DMA transfer. Okay, so now I would like to transfer, the hard disk would like to transfer data to the memory. So of course he need to knock the door for DMA. DMA, I have data to transfer. Okay, and then the disk controller will send each byte to the DMA, and then the DMA controller will transfer directly all the data that it received from the hard disk drive into the memory. So without having to go through the CPU. Okay, so copy here to the main memory. Okay, when the amount that is requested is already completed, okay, when C equals to 0, then the DMA will interrupt the processor. Hello processor, all the data that you want is already available in main memory. So you can use it now. Okay, so that's the main idea of DMA. Right? Okay, so there are 3 configurations for DMA. So one is a single bus detached DMA, whereby everything in your machine is attached to one single bus. Okay, you can also have single bus, okay, but you have an integrated DMA I/O, meaning that your I/O devices are separated. They are not attached to the bus as well, but they are now directly communicated with the DMA. Okay, so this is single bus integrated DMA I/O. Or else you can use a specific bus for I/O. Okay, you have the system bus. Okay, this one is connecting the processor, DMA, and memory. And you have another bus, which is I/O bus, which you will use to connect all your I/O devices. Okay, so these are the three configurations for DMA. Alright, so maybe before I end the session, okay, so let's look at your answer here. Okay, program I/O. Alright, what else do we have? Okay, so this one I'll continue in the tutorial. Okay, so I will end the session, and the rest of the lecture slides we will discuss in the tutorial. Right? Okay, so please scan the QR code. Update the passcode for your attendance. Okay, I will end the session here. Thank you so much. So I will see you guys next week on Friday. Class on Friday is on as usual. Okay. Again, I would like to remind you, please check my latest 3 announcements. Okay, in the announcement section. Please go through. Right, thank you so much.